Galaxies are enormous collections of stars, gas, dust, and dark matter that are held together by gravity. They come in a variety of shapes and sizes, ranging from spiral galaxies with elegant spiral arms to elliptical galaxies that are more like shapeless blobs. Galaxies are fascinating to astronomers because they provide clues about the history and evolution of the universe. However, one of the biggest mysteries in astronomy is how galaxies form. Despite decades of study, scientists still don't fully understand how the first galaxies came into being, how they evolved over time, or how they interact with each other. Galaxies and their classification. Galaxies are massive collections of stars, gas, dust, and dark matter that are bound together by gravity. There are three main types of galaxies: spirals, ellipticals, and irregulars. Spiral galaxies are perhaps the most recognizable type, with their characteristic spiral arms that wind around a central bulge. The Milky Way, our home galaxy, is a spiral galaxy. Spiral galaxies are further classified as either barred or unbarred, depending on whether they have a central bar-shaped structure or not. Elliptical galaxies are less structured and tend to be more elliptical in shape, hence their name. They are generally composed of older stars and have little to no ongoing star formation. Elliptical galaxies range in size from small dwarf galaxies to massive giants that are over 1,000 times more massive than the Milky Way. Irregular galaxies have no particular shape or structure and often appear chaotic. They may have been formed through interactions or collisions between other galaxies, or may simply be in the process of forming. They can range from small, low-mass dwarf galaxies to large, massive ones. Galaxies are also classified based on other characteristics, such as their luminosity, color, and spectral properties. For example, some galaxies are classified as active galaxies if they have an extremely bright core powered by a supermassive black hole at the center. Others are classified as dwarf galaxies if they are much smaller than typical galaxies, with fewer stars and less mass. Overall, the classification of galaxies is a complex and ongoing field of study, with astronomers continually refining and updating our understanding of these vast cosmic structures. The history of galaxy formation theories. Over the years, astronomers have proposed many theories about how galaxies form, evolve, and interact with each other. Some of the earliest ideas date back to the early 20th century, when astronomers began to study the structure and properties of galaxies in more detail. One of the first major theories of galaxy formation was the steady-state theory, which proposed that the universe has always existed in more or less its current form, with no beginning or end. This theory fell out of favor in the 1960s with the discovery of the cosmic microwave background radiation, which provided strong evidence for the Big Bang model of cosmology. The Big Bang model proposes that the universe began as an extremely hot and dense state, which expanded and cooled over billions of years. As the universe cooled, matter began to clump together to form stars, galaxies, and other structures. Early versions of the Big Bang model had difficulty explaining the large-scale structure of the universe, such as the distribution of galaxies and clusters of galaxies. Modern theories of galaxy formation have evolved considerably since the early days of cosmology. One of the most popular models is the cold dark matter, or CDM model, which proposes that the universe is made up of a mix of normal matter and dark matter. Dark matter is a mysterious substance that does not interact with light or other forms of electromagnetic radiation, but has a gravitational effect on visible matter. According to the CDM model, dark matter played a key role in the formation of galaxies, helping to pull matter together and form the large-scale structures we observe today. Another model that has gained popularity in recent years is the hierarchical model of galaxy formation. This model proposes that galaxies formed through a series of mergers and interactions between smaller, less massive structures. According to this model, the first galaxies were small and irregular in shape and grew over time by merging with other galaxies or absorbing smaller structures. This process is thought to have continued over billions of years, leading to the diverse range of galaxy types we observe today. Overall, our understanding of galaxy formation and evolution is constantly evolving as new observations and theories are developed. While many questions remain, astronomers are making steady progress in unraveling the mysteries of these vast and complex cosmic structures. Challenges in understanding galaxy formation. Despite decades of study, the formation of galaxies remains one of the biggest challenges in astrophysics. There are several key obstacles that astronomers must overcome in order to fully understand how galaxies form and evolve over time. One of the biggest challenges is the role of dark matter in galaxy formation. While dark matter does not interact with light or other forms of electromagnetic radiation, its gravitational effects can be observed indirectly through its influence on visible matter. Many models of galaxy formation rely heavily on dark matter, which is thought to have played a key role in pulling matter together to form the first galaxies. However, the nature of dark matter remains a mystery, and many questions remain about how it interacts with other forms of matter and how it influences galaxy formation. Another challenge is the formation of supermassive black holes, which are thought to exist at the centers of most galaxies. These black holes are incredibly dense and massive, with the ability to swallow up entire stars and other matter. However, it is still not clear how these black holes formed in the first place, or how they grew to such enormous sizes. Some theories propose that they formed from the collapse of massive stars, while others suggest that they grew through mergers with other black holes, or by accreting matter from surrounding gas and dust. Additionally, the formation of the first galaxies is still not well understood. It is thought that the earliest galaxies were small and irregular in shape, but it is not clear how they formed or how they evolved over time. Observations of distant galaxies can provide clues about their early history, but these observations are often difficult and require advanced telescopes and techniques. Overall, understanding galaxy formation is a complex and ongoing field of study that requires a deep understanding of astrophysics, cosmology, and particle physics. While many challenges remain, astronomers are making steady progress in unraveling the mysteries of these vast and complex cosmic structures. Recent discoveries and breakthroughs. In recent years, there have been several exciting discoveries and breakthroughs in the field of galaxy formation and evolution. These discoveries have provided new insights into the processes that shape galaxies and the nature of the universe as a whole. One of the most groundbreaking discoveries in recent years was the detection of gravitational waves, which were predicted by Einstein's theory of general relativity. In 2015, the Laser Interferometer Gravitational Wave Observatory, or LIGO, detected the first gravitational waves from a merger of two black holes. Since then, several other gravitational wave detections have been made, including a merger of two neutron stars in 2017. These detections have provided new insights into the nature of black holes and the behavior of matter under extreme conditions. They have also shed light on the formation and evolution of galaxies, as black holes are thought to play a key role in shaping the structure of galaxies and their surrounding environments. Another recent discovery that has generated a lot of excitement is the discovery of ultra-diffuse galaxies, or UDGs. UDGs are a type of galaxy that are much larger than typical dwarf galaxies, but have much lower levels of star formation, and are therefore much fainter. They were first discovered in 2015 and have since been found in abundance in galaxy clusters and other environments. The discovery of UDGs is challenging many of our assumptions about galaxy formation and evolution. They appear to have formed in environments where the gravitational forces are relatively weak, which suggests that the traditional models of galaxy formations, which rely heavily on dark matter, may not fully explain their properties. Overall, these recent discoveries are pushing the boundaries of our understanding of galaxy formation and evolution. They are providing new insights into the nature of the universe and the processes that shape the galaxies and other structures within it. As new telescopes and observation techniques are developed, we can expect even more exciting discoveries in the years to come. The future of galaxy formation research. The study of galaxy formation and evolution is an exciting and rapidly advancing field of research, and there are many exciting directions that future studies could take. Some of the key areas of focus for future research in this field include studying the earliest galaxies. Observing and studying the earliest galaxies in the universe can provide important insights into the processes that shape the universe and the formation of the first galaxies. Some telescopes, such as the James Webb Space Telescope or JWST, are capable of detecting some of the earliest galaxies and shedding light on their properties and formation. Observing galaxies in more detail. The development of new telescopes and observation techniques is allowing astronomers to observe galaxies in more detail than ever before. For example, the Atacama Large Millimeter Submillimeter Array, or ALMA, is providing unprecedented views of the cold gas and dust that make up galaxies. Future instruments such as the Wide Field Infrared Survey Telescope, or WFIRST, and the European Extremely Large Telescope, or EELT, will allow astronomers to study galaxies in even more detail and provide new insights into their properties and evolution. Simulating galaxy formation. Simulations of galaxy formation and evolution have become increasingly sophisticated in recent years, allowing astronomers to test different models and scenarios for how galaxies formed and evolved over time. Future simulations will continue to improve in accuracy and complexity, providing new insights into the physics that govern galaxy formation and evolution. Multi-wavelength studies. Studying galaxies across a range of wavelengths, from radio waves to gamma rays, can provide a more complete picture of their properties and evolution. Future studies will likely continue to focus on multi-wavelength observations and the development of new instruments and techniques that can probe galaxies across a wider range of wavelengths. Overall, the future of galaxy formation research is promising, and there are many exciting directions that it could take. By continuing to observe and study galaxies in detail, and by developing increasingly sophisticated models and simulations, astronomers will be able to gain new insights into the mysteries of galaxy formation and evolution. Finally, the formation of galaxies remains one of the most fascinating and important mysteries in the universe. By continuing to observe and study galaxies in detail, and by developing increasingly sophisticated models and simulations, astronomers will be able to gain new insights into the mysteries of galaxy formation and evolution. The ongoing pursuit of understanding galaxy formation and evolution will not only lead to a better understanding of our universe, but also a better understanding of our place within it. Thank you for watching, and please subscribe to the channel.